Hello guys and welcome to a new physics session. Today inshallah we are going to study two new physical terms. One of them is sound and the other one is light. Let's firstly start. What is the properties of the sound wave? Scan the QR code, which is a video, then return back to me. What is the sound, guys? Sound is a mechanical wave, a type of mechanical wave. We studied before that mechanical wave is a type of wave which you need a medium to travel through. So the mechanical wave the mechanical wave is a type of wave which you need a medium to travel through, as we said before. Mechanical wave depends on the vibration of medium particles. So we said that mechanical wave has two types. One of them is transverse, and the other one is longitudinal. The difference between them is the way of the medium particles vibrate. Today, our study of sound wave belongs to longitudinal wave, in which the medium particles vibrate along the wave direction. We said before, wave direction is the direction in which the sound wave can travel, or the wave itself can travel through. So when the medium particles vibrate in the same direction of the wave transferring, so we call it longitudinal wave. Longitudinal wave, as we said before, consists of two parts. The first one is compression, and the second one is rarefaction. So in this figure, we have two waves. The first one consists of compression and rarefaction. The second wave consists of two parts, which are compression and rarefaction. Compression is the area in which medium particles are close to each other. The medium particles are close to each other. While rarefaction, the medium particles are reared from each other or away from each other. So, here is the sound wave, guys. We can see that the sound wave consists of two different areas. One of them is the area which is highlighted by dark line, and the one which is highlighted by yellow, highlighted by light is another one. One of them compression and one of them is rarefaction. The source of the sound itself is the center of production of the sound, as the sound wave moves in all directions as a sphere. By increasing the frequency, the number of waves produced in 1 second increases. The number of waves while when decreases the frequency, the number of waves which is produced in 1 second decreases. The amplitude is the thickness, as you can see, guys, is the thickness of the wave itself, which is the maximum displacement from the rest point. So, as it a longitudinal wave, the thickness of the wave itself, the thickness of rarefaction or compression will increase. What are the properties of sound wave, guys? We have 3 different properties which differ between sounds of different objects. Like, what are the properties which differ my sound from your voice, or my voice from your voice? What are the properties which differ between the sound of violin and the sound of donkey? What are the properties which differ between the sound of a car crash and a car race? The properties are sound intensity, which is the first one. Sound intensity, sound loudness, sound pitch. Sound intensity, the physical quantity that measures the power, intensity, the power of the sound itself, per unit of area. This is proportional to the square of the amplitude of the wave. As the wave amplitude increase, the sound intensity increase. As the wave amplitude increases, the sound intensity also increases. Sound loudness, it's how strong the sound is. It measures how strong the sound is. So, the preserved perception of how strong or weak a sound is often related to how loud or quiet a sound feels to a human ear. So I can speak loudly or I can speak quietly, which is the sound loudness. Sound pitch is the properties which compare between soft sound and rough sound, like the sound of a girl and boy, the deep sound and the light sound, the one which is soft. Sound intensity is measured in decibel. Sound loudness, high or loud, it has no measuring unit. Sound pitch is described, it measured in hertz as a frequency, depends on the frequency of the sound. So the sound pitch depends on the frequency of the sound. As we said before, the sound intensity depends on the wave amplitude. So, and it depends on the wave amplitude. As the wave amplitude increase, the sound intensity also increase. But the relation between sound intensity and the wave amplitude is inverse, is directly proportional with the square value of the amplitude, while the relation between sound intensity and the distance is the inverse square law, which is represented by the inverse square law, which saying that the sound intensity is inversely proportional to the square of the distance between the source of sound and the receiver of sound. As we said before, sound pitch depends on the frequency of the sound. Higher frequency means a higher pitch, and vice versa. What is the meaning of Doppler effect, guys? Doppler effect is the effect of changing the frequency of a sound as the receiver is moving, or the object itself is moving, or both of them are moving. If you are listening to a car engine sound, which is coming from a long distance, coming from far distance, you're going to find that as the car moving towards you, the frequency and the frequency of the sound itself differ as the pitch of the sound differ. We said before, sound pitch depends on the frequency. So, the sound of the car engine, let's say it's a race car, it differ according to the distance which is away from you, the distance between you and the source of the car. If the car itself moving, so the frequency produced by this car is also changed. So the Doppler effect is the change in frequency of a sound is caused by the movement, as we said, the movement of either the source, the detector, or both of them. How to find the new frequency? Or we can call it the frequency of Doppler effect. We have the frequency of the source, and we have also the velocity of the source. So the Doppler effect will be V minus Vd, which is how to find the frequency. Guys, how to find the frequency of the Doppler effect, or the effect which changes the velocity. Wait. Guys, how to find the frequency of Doppler effect? As we said before, the frequency of Doppler effect depends on the frequency of the source itself, the main frequency of the source. So the frequency will be the frequency of sound minus the frequency, the velocity of the sound minus the velocity of the detector, the observer, divided by the velocity of the sound minus the velocity of the source itself. So we have two cases, guys. One of them when the detector is stationary while the source is moving, or by another way, if the detector is moving and the source is stationary. So we have three rules. If both of them are moving, we are going to use this rule. If one of them is moving, so I'm going to put the value of this object, the value of the velocity of this object by 0. So if the object is moving while the detector is stationary, that means Fd will be Fs multiplied by V over V minus S. This rule represents the movement of the source while the stationary or detector itself is stationary. And also, the second rule is Fd equal to Fs V minus Vd over V, while V0 is 0, Vs is 0, as the source is stationary, while the... وانا ليه بهبل؟ عيد تاني من الحتة بتاعت الاف دي اللي هي الأخرانية دي. While the rule will be Fd equal Fs V minus Vd over V. In this case, the Vs, which represents the source velocity, is 0, as the source itself is stationary, while the detector is moving. So it will be V minus Vd over V. Here's, guys, the two rules. As a stationary source, so Vs will be 0, and the rule will be V over 1, the rule will be Fd equal Fs 1 over 1 minus Vs over V, which is the same rule which we wrote before. Fd equal Fs V minus Vd over V. It's the same rule. And this one also is stationary detector, so Fd will be 0. So Vd will be 0. So Fd will be equal to Fs V minus 0 over V minus Vs. I think these rules are more easy. So you can only memorize one rule and then substitute it in it using the detector velocity is 0 as the detector is stationary, or the source velocity equal to 0 as the source if the source is stationary, if the source is stationary. Which of the following best describes a sound wave, guys? Well done. It's a mechanical longitudinal wave that requires a medium to travel through. What is the unit of sound intensity? It's a decibel. Well done. What determines the pitch of the sound? As we said before, it's the frequency of the sound wave. Moving to another part in sound. What is the meaning of resonance in air column? Scan the QR code, which is a video, and return back to me. The resonance, guys, is the vibrating of the wave inside a tube. And we have two types of tubes. One of them called open tube, so the both ends of the tube are open, and a closed tube, which is represented by a tube has only one open and the other side is closed. A resonating tube with one end closed to air is called closed pipe resonator, like clarinets and hanging pipes under xylophones are examples of closed resonators. As we said, we have two types, open tube and closed tube. We define them. The open tube has a new frequency has a harmonic, new harmonic, which is found by. طيب من أول الحتة بتاعت الأوبن تيوب اشيلها عشان نشرح. Here's guys how the sound vibrate inside open tube by two ends or even a closed from one end. Let's consider that the length of the tube is L. The length of the tube is L. So when the wave, I'm going to draw it. When the wave is when the wave vibrates inside the when the wave vibrates inside the tube. So here is the main wave, and here is the resonating one, the vibrating one, the image of the wave. So in this case, we call that we have the first harmonic motion. Why first harmonic motion? Because we have only one wave. Here's half wave and half wave. So we call it first harmonic motion. But the second one, the second harmonic motion, we have the same length and we have two waves inside the pipe. Here is the first wave and here is the second. So we call it the second harmonic motion. For the third, we have three waves. Here is one, and here is another two. The fourth by the same way. So for the two open ends, we have a complete waves oscillate inside the pipe, which produce a complete waves. The vibration produces complete waves. So as we can say, the wavelength for the first harmonic motion is equal to هنبدأ من أول السلايد دي خالص. لازم أعيدها من الأول. تمام؟ طيب. So guys, we have two types, as we said, we have two types of tubes. One of them is two open ends and the other one is one open end. What is the difference between them? Let's firstly talk about the two open ends tube. And the first harmonic. What is the meaning of first harmonic? Harmonic, that's mean only one oscillation happen inside the tube. As we said before, here is the pipe. Let's consider the length of the pipe L, and the wave is vibrating inside it. So the wave going to reflect back. Sorry. نعيد الرسمة. So the wave going to reflect back and produce another oscillating wave. As we said before, guys, the wavelength is the distance between two similar points. If the distance if the distance from this point to another one, which may be here, if I completed the drawing, here will represent a wavelength. So this distance similarly represent half wave. Which is mean L is equal to half the wavelength. So the wavelength for the first harmonic motion, first oscillation inside two open ends pipe is equal to double the length of the tube. The wavelength is equal to double the length of the tube. Here it is. If I'm describing the second harmonic motion, so it's going to vibrate inside the tube twice. So it will produce one complete wave. Here is half wave and another quarter and another quarter, so it will complete one wave. So the wavelength in this case is equal to L. Third harmonic motion will produce 1.5 wave. So the wavelength is equal to 2/3 of the length of the tube, and so on. We can conclude that if I'm talking about the first harmonic motion, so it will be 2L/1. If I'm talking about the second harmonic motion, so it will be 2L/2. If I'm talking about the third harmonic motion, it will be 2L/3, and so on. So we can put a general law for the length, for the wavelength of a sound wave which is oscillating inside the tube. It's equal to 2L divided by N, and N is the order of harmonic motion. Is the order of what? Harmonic motion. Let's move to the closed one. It's only produce first oscillation, only one oscillation. I'm going to talk about first harmonic motion. So the first oscillation in the closed pipe will reflect at the closed side. So it will be produced by this way, guys. Here is the pipe, and here's the wave moving like this, then returning back in reflection like this. If we need to complete this wave, we will find that this part is equal to 1/4 from the original wavelength. So the wavelength in this case is 4L, as the length of this pipe represented by L. So for first harmonic motion, the wavelength is equal to 4L divided by 1. For the second harmonic motion, the wavelength is provided by 4L divided by 3. As we can see inside this tube, there is a 3/4 of the wavelength. So L in this case is 3/4 of wavelength. So the wavelength is 4/3 from the length of the tube. By the end also we can make another rule, which is saying that for L/N. But guys, for the closed tube, we are unable to make second harmonic and third harmonic. We are unable to make second harmonic and fourth harmonic and sixth harmonic and so on. We are only moving with odd number. The difference between شيل the difference between دي وهنبدأ نشرح. خلاص همسح بس الحاجات دي كلها. Second. Let's say that, guys, here is the tube and here is the first harmonic motion. If I would like to find the second harmonic motion, let's say that there is a second harmonic motion enclosed in the tube and I would like to draw it. Here is the tube. So I would like to draw it like this. It's the same of the first, so it's wrong. I will try to draw it like this. The drawing represents the real act in life. So I will come from here to draw this like this and then divide it and return back here to make it out. And this, it represents the third, not the second. Here's quarter, here's quarter, here's another quarter. So I'm not able to draw the second harmonic motion. If I'll try to avoid this one and draw it like this, the reflection will be out of the pipe. So there's no second, there's no fourth, there's no sixth, there's no eighth, there's no, and so on. So in the one open or one closed end pipe, we deal only with first harmonic, third harmonic, fifth harmonic, and seventh harmonic, which means the odd harmonic motion. As it's not applicable to the wave or the wave itself. The wave itself are unable to vibrate inside the pipe with even number. It has to do 3 vibration, at least one quarter of one vibration, 3 vibration. It's unable to do 2 vibrations, as the first part of the wave is a quarter. So if I would like to draw the second part, which complete half wave, which complete this one half wave, it will be outside the pipe, and so on. As this part exists outside the pipe, so it's not counted. It's not counted. So guys, let's find the frequency of open tube. Anyhow, we said before, V is equal to the wavelength multiplied by frequency. So if I would like to find the frequency, so the frequency will be V over lambda. For first harmonic motion, we said F equal to V over lambda. Let's talk about two end open tube. If I'm talking about the first itself, so it's Fn equal, we said before, for the first harmonic motion, for the first harmonic motion, wavelength is equal to 2L over N. Is this true? So the first one will be V over 2L divided by 1, so multiplied by 1 here. For the second, so it will be 2L over 2, which is mean V over L. For the third, it will be 2L over 3, so it will be 3V over 2L. So the rule will be Fn equal NV over 2L. Here is the rule to find the frequency of a certain harmonic oscillation for a sound wave in two end open tube. While for one closed end, the rule was of wavelengths the wavelengths will be the wavelengths will be 4L over N. And as we said before, there is no 2, 4, 6, there is no even number. Only N is equal to odd numbers, which is 1, 3, 5, and so on. So the first harmonic oscillation is equal to 4 is equal to V over 4L divided by 1, so times 1 here. The second, there is no second, the third is equal to V over 4L divided by 3, so it will be 3 here. Which is mean the main rule of the frequency in a closed end tube will be Fn Fn is equal to NV over 4L, as N equals to 1, 3, 5, odd numbers. Equal to odd numbers. ازاي؟ فاهم صح. كل اللي انا قلته الاول غلط. Result. In the questions, guys, he don't ask about first. In the question, guys, he don't ask about first harmonic motion. Only, or second harmonic motion, or third harmonic motion. Sometimes his question will be find the first resonant, find the second resonant. In two open ends tube, the first resonant represent first harmonic. The second resonant represents second harmonic, and so on. But the first resonant in the closed tube, closed end tube, one side is closed. The first resonant is represent the first harmonic. Well done. The second resonant represent the third harmonic. So we have two ways to solve the question itself. Focus, guys. If he's going to ask with first, third, fifths, so we were going to use the normal law as for closed, let's say for open, Fn equal NV over 2L. And this rule doesn't differ if he said resonant. If he said resonant, first resonant, second resonant, and so on, we are going to use the same rule, Fn equal NV over 2L. The problem only in the closed end. If he asked about first harmonic, first harmonic, third harmonic, fifth harmonic, we will use the rule Fn equal NV over 4L, which is correct for the word of harmonic. In case he asked about harmonic. So guys, during the questions, he's not saying only find the first harmonic, find the second harmonic, find the third harmonic. Sometimes he asks about the resonant. Sometimes he asks about resonant. The word is resonant. And resonant here mean n. And resonant here means n. So we have the word of harmonic, and in case of harmonic, so we have a closed to open, closed end tube, or to open end tube. The rule of to open end tube will be Fn NV over 2L. The rule of closed tube, Fn equal N V over 4L. Here, N is equal to 1. N is equal to 1, 2, 3, 4, normal 1. But here N is equal to 1, 3, 5, and so on, odd numbers. If he mentioned a word of resonant, the rule of the harmonic will be the same for two open ends. No difference between them, as n can be equal to 1, 2, 3, 4, 5. But for the resonant, if he gave you n equal 1, there's no problem. But if he give you n equal 2, how can you find it? N is 2, is the second resonant. The second resonant means the third harmonic, because it is the second vibrating, it's the second vibration. So we can change the rule in the case of closed end tube, so to satisfy or to deal with the word of resonance to be Fn is equal to 2n to be equal to 2n minus 1 by the same way V over 4L. If you are in the first harmonic motion, first resonant, so it will be this part which represent n in the ordinary rule will be 2 times 1 minus 1, so it will be 1, n equal 1. But in the second resonance, the second oscillation, which is representing the third harmonic motion. So second, that means 2 times 2 minus 1 will be third harmonic. So n is equal 4, returning back to the previous or the main rule. So it depends on the question itself, guys. In the case of two open ends, no problem. Use the main rule, which is equal to Fn NV equal NV over 2L. But in the case of closed end tube, focus with the question. If the question is saying that second harmonic, third harmonic, if the question is saying that third harmonic, first harmonic, fifth harmonic, the word of harmonic is represented. So you have to use this rule. But if he said first resonant, that means first oscillation, second oscillation, first oscillation represent first harmonic. But second oscillation represents third harmonic. Third oscillation represents fifth harmonic. So if he said oscillation, if he said resonant, so you have to use the rule of Fn 2n minus 1 V over 4L. If he said the rule of, if he said the word of harmonic, use this rule, guys. So as we can see, we have two rules. One of them is the resonant, resonates, and we said also resonates, that's mean Fn equal to n minus 1 V over 4L. Here n can be equal 1, 2, 3, 4, and so on. But the word harmonic differ only in the case of the closed tube. It must be Fn equal to NV over 4L, as n is equal to 1, 3, 5. So the key words are harmonic and resonance. Harmonic and resonance. This table describes what we already said, guys. Or harmonic motion. By the way, guys, the first harmonic motion, sometimes he call it fundamental. The first harmonic motion, by the way, guys, he calls it fundamental. Fundamental, that's mean first. So if asked about fundamental, that's mean first harmonic motion or first even resonant. What is the difference between, guys, knot and anti-knot? Knot, guys, is the area of the intersection between the two waves. This part is called knot. This part is called knot. This part is called anti-knot. So the intersection between the two waves, the main wave and the reflected one, the intersection between them is knot. The intersection between if the area produces the maximum amplitude and there is no intersection, so it's called anti-knot. Anti-knot location 4. Open tube. It exists at both ends of open ends. It exists at both open ends. I'm talking about anti-knot. And the anti-knot of closed tube is exist at the open end, as the closed end contains knot, not anti-knot. We can return back to the drawing. Anti-knot. So the anti-knots for the two open ends exist at the open end. Each open end consists of anti-knot, while the knot itself exists at the center between anti-knots. While one open or end or a closed end tube, the open side contains anti-knot, while the closed side contains knot. Resonance on a string, guys. It's the same exactly an open tube. When a string is vibrate and this string is fixed from two sides, the string is fixed from the two ends, from the both ends or from the two sides, this string going to vibrate in a shape similar to the vibration of a wave inside two open end tubes. And we'll have the same calculation, by the way. What is the first resonant? He He is asking about resonant frequency of a closed tube. Closed tube. If the length is 2 meters and the speed of the sound is 340. Resonant, so I'm going to use the rule of 2n minus 1 v over 4l. So, by solving this question, guys, Fn will be equal to 2n minus 1 v over 4l. Here is the L, the length of the tube, L. And here is the V, velocity of sound. So Fn will be 2 times 1 minus 1 will be 1. As I said to you guys, there's no difference between first resonant and first harmonic in the closed tube. It will be the same rule, multiplied by 340, divided by 4L, which is mean 8. So the answer will be 42.5 Hertz. An open tube, where are the antinodes located? Antinodes, well done, at the both ends of the tube. Which harmonic represent in a closed tube? Which harmonic? First harmonic, second, fourth harmonic, sixth harmonic, only odd harmonics, first, third, fifth, and so on. Of course, answer number D. In a closed tube, where is the node located? Closed tube. Closed tube. The node is located at the closed side, صح? At the closed side. At the closed end. So the answer will be at closed end. Moving to a new part, which is light, guys. What is the light? Let's say that the light is electromagnetic wave. So as the light electromagnetic wave, it can travel through space. Electromagnetic wave doesn't need a medium to travel through it. It can travel through space, and also it can travel through medium. By this way, we receive the sunlight through the space. What is the type of a wave that carries the light energy? Electromagnetic wave. Scan the QR code, watch the video, and turn back to me. Ray model of light. When we was young, guys, we were drawing. When we were young, guys, we were drawing the sun as a circle. You can remember that, as a circle, and the light coming from the sun as rays. So the ray model of light is represented by, as a ray, the light is represented by a ray travels in a straight path, the direction of which can be changed only by placing an obstruction in this path. And we're going to study it later. So the ray model represents the light by rays moving in a straight line, as we were drawing it when we were young. We have two sources of light, guys. One of them which emit light, and another one which reflect light. The source of light, like sun, we call it luminous source, as it emits light by itself. The source of the object which is reflecting light and unable to form light by itself, we call it luminous object or luminous source. Objects you see due to the light reflecting from them. By the way, the only way to see an object by reflecting a light on it or by emitting light. Your eyes don't produce light to see. If the room is closed, so if the room is closed, so you will be unable to see objects. If the room is dark, you will be unable to see the objects. We have 3 different types of medium according to transmitting or passing light. The first one is opaque medium, the second one is transparent medium, and the third one is translucent medium. The opaque medium is the medium which reflects back all light and doesn't permit the light to pass through it. So the opaque medium, again the opaque medium is the type of medium which reflects back all of the light falling on it without permitting any amount of light to pass through it. The transparent medium is the medium which doesn't reflect back any light, or by another way, it reflects very few amount of light back and let or permit most of the light to pass through it. Translucent, the one which form hesitated image, as it prevents some and allows some. Prevents some light to pass through it and allows some light to pass through it. So opaque medium is a medium such as brick that doesn't transmit light but reflects and absorbs light. Transparent medium is a medium that transmits most light, such as air and glass. Most light. It reflects a few amount of light back. So by this way you will be able to see it, like the glass. You are able to see the glass because some light can be reflected on it. So you are able to see it. If this glass is very pure and very clean, you will be unable to see it. Translucent, a medium that transmits and reflects light but doesn't permit object to be seen clearly through it. It forms something called hesitated image, like the frosted glass. Okay guys, I need to measure the amount of light. The amount of light can be measured by 2 ways. By the source of light, the amount of light emitted from the source, or by the amount of light falling on an object. The amount of light falls on an object. So, luminous flux, which is P, luminous flux is the rate at which the light energy is emitted from luminous source. So we call it luminous flux. Its measuring unit is lumen, and the abbreviation is LM. While if I'm going to measure the light intensity using the amount of light which falls on an object, so I'm going to use another term which is called luminous, and its symbol is E, not P. The luminous flux falling on a given surface area at any instant of time. It has a measuring unit of lux, LUX, which has abbreviation of LX, and equivalent to lumen per meter squared. Equivalent to lumen per meter squared. So we can say that lux is equal to lumen per meter squared. Okay, guys, I need to measure surface illumination. The amount which is required to make a certain area bright. So it's a relation between the emitted amount of light by a certain source, or sorry, it's the استنى كده هنعيد تاني. So it's a relation between the emitted light produced by it's a relation between the emitted light produced by luminous source and the amount of light which falls on an object. And we call it E. We call it E. Illuminance. We can use it by E is equal to, or we can calculate it by E equal P over 4 pi r square, as R is the radius of illuminated area. So, to increase the brightness, you could use a brighter source, increasing the luminous flux, or you can move closer to the هنعيد تاني خالص الحتة دي من أول السيرفيس illumination. خلاص؟ ليش هو للأسف ساعات واحد يغلط. Surface illumination, guys. Surface illumination is the amount of, as we said, illumination is the amount of light which is falling on a certain surface. So, and we said before also the luminance is measured by E, which is intensity of light falling on an object. If here is an object which is luminous, and this object produces light. This object produces light, and the light moving in all directions, transferring in all directions, in the form of a sphere. So the area of this sphere is four pi r square. If there a source of light which exists, is there an object which exists here as a distance equal to the radius of this sphere? So the rule of illuminance, we call it point source. That's mean the luminous object itself is very small according to the object. we can use the rule of E equal P over 4 pi r squared. طبعا انا مش عاجباني اي حاجه من اللي انا بقولها دي. Surface illumination guys. Surface illumination is talking about the amount of light falling on an object. If we need to find the brightness, or to increase the brightness on an object or decrease the brightness, you can change two different terms. One of them is the distance of the object from the luminous object or from luminous source, or decrease the luminous itself, intensity itself, decrease the luminous intensity itself. So, to increase the brightness, you should use brighter source, increasing the luminous flux, or you could move closer to the light, decreasing the distance. So, if we have a luminous source exists here, and the source produces the light in every direction, in each direction, and there is an object exists here. So the amount of light intensity or the light brightness which falling on the object can be calculated by E equal P over 4 pi r squared, as R is the distance between the source and the object, or can be represented by R is the radius of this area surrounding the luminous source. But note that, guys, this equation is only calculated if the light strikes perpendicular to the surface it is illuminating, which means the light is falling perpendicular on the object, and the luminous source is small enough or far enough away to be considered as a point source, as this rule describes the point source. Point source, that means the object or the luminous source itself is very small, to be able to make a bright or illuminate a certain part of the object. Which of the following is true about luminous flux? Well done. It measured by LUX. Here is an answer which is saying that it's a measure of the total light emitted from the source. It's not a total, guys. It's a rate at which the light energy is emitted. It's not a total. If he's saying that it's a measure of the rate of light emitted from a source, that will be the luminous flux. But in this choice, he said that the total amount. The total different from rate. The true definition is rate of light, not total light. Rate means amount of light by time. How many lights is produced from the object or from the source at certain time in 1 second. We call it the luminous flux. So be careful while choosing your answer. Total is a wrong word and wrong description. What is the unit of luminous flux? Lumen. The wave nature, guys. If you are talking about the wave, so the wave itself is consisting of, so if we are talking about light, the light of self, which we're calling it أنا بحضر من غير ما أحضر، ده مش صح عشان بجري. The wave nature of light, guys. What is the light? What the light which are unable the light is consisting of 7 spectrum colors, as we know, guys. The 7 spectrum colors are mixed together. The 7 spectrum colors are mixed together to produce the white light, which we able to see it. So here is a prism, guys, the one which analyzes the light, and here is a source of white light. Here is a source of white light, guys, and I'm going to put a prism in front of it. So as you can see, guys, the light is analyzed into different colors. We call it spectrum colors. The analysis of this light is according to the wavelengths and the frequency of each spectrum color. As the light with low frequency and high wavelengths is the first one observed, and the light with low wavelengths. هنشوف لك تاني، مش نسيت اقول ايه. The red light, guys, is the one with high wavelengths and low frequency, which is the first one observed. The violet light, guys, is the one which is low wavelengths and highest frequency, so it is the last one observed. as the wavelength of the light decreases, the light diffract more or even أنا مش عارف أشرح ليه. مش عارف وقفت فين، فبص انا هعيد من اول اللي هي الديفراكشن اكسبكتد معايا من اول هنا خالص، هعيد تاني عشان انا اول مره مش عارف اشرح. So guys, we have now a source of light. So guys, we have now a source of white light. As we can see, the light is moving in a straight line. By putting a prism in front of the light, we will find that the light is split into different spectrum colors. The first one is red with the highest wavelength and lowest frequency, and the last one is violet, which with the lowest wavelength and highest frequency. So when a narrow beam of sunlight or white light, which is consisting of 7 spectrum colors as we said, passes through a glass prism, it splits into different colors, starting from red to violet. Red is the highest wavelength with lowest frequency, while violet is the lowest wavelength and highest frequency. We have different classification, guys, of light, of colors, primary colors and complementary colors. And also we have different classification of pigments, primary pigments and secondary pigments. What is the difference between colors and pigments, guys? The difference between color and pigment: color refers to the different wavelengths of light that our eyes perceive, which is mean the light which we able to see it, while the pigment is the color of object itself. So pigments are substances that absorb certain wavelengths of light and reflect others. So the difference between colors and pigments, guys, is the difference between or how they are produced and preserved. If you are talking about the light itself, so we have to mention colors. We say colors. Colors means the color of light. The color refers back to the light. Pigment refers back to the color of objects. The colors of objects. هنشيل الحته الاخرانيه دي انها كانت عبيطه وخلينا في الاولانيه، مش لازم اعيد الكلام واشرحها مرتين. So colors, guys, primary color, white color, can be formed by adding red, green, blue. So we call them primary colors. While complementary colors are two colors of light that can be combined to make white color. So if we have two colors, only two colors, these two colors going to mix together to produce white color, we call them complementary color. And for the primary color, there are only three colors, which are red, green, and blue. Here's, guys, the three primary colors: red, green, and blue. If I'm going to operate them by the same value, so you notice that this guy will observe a white color because I mixed the primary colors with the same amount. I mixed the primary colors with the same amount. So the produced color is white. The complementary colors are only two colors of them can mix to produce this white color. Can be mixed to produce this white color. Pigments, as we said, pigments are the color of objects itself. So a pigment is a pigment that observes only one primary color and reflects two from white colors. It's called primary color. It's called primary pigments. So it absorbs one and reflects two. Secondary pigments are pigments that absorb two primary colors and reflect only one color. So if I'm talking about primary like cyan, magenta, yellow. Secondary colors like red, green, blue. By mixing, red is provided by mixing magenta and yellow, and the absorbed one is cyan. Green is by mixing cyan and yellow, and the absorbed one is magenta. Blue by mixing cyan and magenta, and the absorbed one is yellow. So, what is the polarization of light, guys? As we said before, light is produced in different directions as a circle or even a sphere. If I'm talking about one dimension, so it's produced in the shape of a circle. If I'm talking about the 3 dimensions, it's produced as a sphere. But polarized light is the light which is produced in one direction, certain one direction, like laser, guys. Laser is called a polarized light. Laser is produced only in one direction, not different direction. So the polarized light is the production of light with a specific pattern of oscillation. Light is not polarized. Light is non-polarized when electric field of a light wave oscillates in random directions. As by the same way as the wave of sound makes Doppler and the frequency of the wave the sound wave changes according to the movement of light, and the frequency of the sound wave is changed according to the movement of the source or the observer. Also the light frequency changes and produce something called Doppler effect. So when light source is moving relative to an observer, the light Doppler shifted and the frequency changes. We use the same rule, guys, We use the same rules, guys, of Doppler sound. So the observed light frequency is by the observer is the frequency of light multiplied by 1 plus or negative 1 P over C. Plus or negative depends on if the object is moving towards if the object is moving towards the if the source is moving towards the object or away from the object. The equation can be used only if in the situation in which the axial relative speed is much less than the speed of light. The equation of the Doppler effect for light is generally written in terms of wavelength rather than frequency. If I'm going to write this one, طيب احنا هنشيل the Doppler effect of light, guys. When a light source is moving relative to an observer, the light is Doppler shifted and the frequency change. As we said, guys, in sound wave, the frequency of Doppler is equal to the frequency of the source multiplied by V minus Vd divided by V minus Vs. Vd is the velocity of the Vd is the velocity of the observer, while Vs is the velocity of the source. The velocity of the light has a symbol of c. So c is the velocity of white light. So we can change this rule n2 to be m2. F is the velocity of observer. We will write observer equal to the frequency of light multiplied by c minus the velocity of the observer divided by c minus the velocity of object, the velocity of So guys, also light can form Doppler effect like sound. When a light source is moving relative to an observer and this observer is stationary, so the light is Doppler shifted and the frequency change. As you can remember, guys, for a stationary object, the Doppler, the frequency of Doppler effect for a stationary object was Fs multiplied by 1 negative Vs over Vd. So Fd is the frequency of the observer. Fs is the frequency of the light. V is the speed of the source, which we will call it V. While C is the speed of ربي أنا تعبت. Light guys has also a Doppler effect. When a light source is moving relative to an observer, so the observer is stationary and the light source is moving, the Doppler shift and the frequency change. So, returning back to the rule of a stationary detector in sound Doppler effect, we'll find that the rule was Fd equal Fs multiplied by 1 minus Vs over V. Changing this rule according to the terms of light, Fd is the frequency of observer. Fs is the frequency of source, which is the frequency of light. 1. Positive or negative, as positive or negative determines if the object is if the source is moving towards the object or away from the object. Vs is the velocity of the source, so we will call it V, while V is the velocity of the wave. The velocity of the sound wave the velocity of the light wave determined by a physical term called c. C is equal to 3 times 10 of power 8 meter per second, which is a constant value. We can change this rule also to provide another rule calculating the change in wavelength by or depending on the wavelengths, changing the equation from being in frequency to wavelengths. So the change in wavelengths will be positive or negative V over C multiplied by the wavelengths of the light. If the quantity is positive, that means they are moving away from each other. If the quantity is negative, so they are moving towards each other, as we said, guys. We are going to study now, guys, different behaviors of light. The first one is light reflection. What is the light reflection, guys? Light reflection is the returning back of light rays when it falls on an object. So it's going to reflect back, opaque object. So the light is going to fall with an angle and reflect back with another angle. We have two different types of reflection: regular reflection and irregular reflection, or by another way they call it specular reflection or diffuse reflection. What is the difference between them? We have two types of surface, guys. One of them is rough. One of them is smooth surface and the other one is rough surface, guys. Here is the rough surface. Rough surface. When the light ray falls on the rough surface, so it's going to reflect back, guys, in different directions. Here is the light ray. Light rays are falling parallel to each other, so it's going to reflect back in different direction. This one we are calling it diffuse reflection or irregular reflection. While when the light rays fall parallel to each other on a smooth surface, it's going to return back on the same direction with a regular pattern or a specular reflection. So we have two types of reflection. One of them is specular reflection and the other one is diffuse reflection. The specular reflection, when the light rays fall on an object, a smooth surface, and reflect back in the same direction. While when the light rays fall on a rough surface, so it's going to reflect back in different direction, and this type of reflection is called diffuse reflection. We are dealing with or concerning with specular. We are dealing with or concerning with specular reflection. So, if we have a flat surface like a plane mirror, and a light ray, only one light ray, falls on the surface. So this light ray is going to reflect in a specular way, regular form, back. This is an imaginary line. This line is perpendicular to the reflecting surface. This imaginary line. And perpendicular to the reflecting surface at the point of incidence of light ray. So this light ray, we call this light ray is incident light ray. This one is incident light ray, and this one is reflected light ray. The angle between the normal line and the incident light ray is called theta. It's called phi, and it's the angle of incidence. The angle between the normal line and the reflected light ray is called theta, and it's the angle of reflection. Sometimes we call this one theta 1, and we call this one theta 2. Doesn't matter. It returns back to the book or the source which you are using. So phi and theta, or theta 1, theta 2. For plane mirror, the first law of reflection is saying that theta 1 is equal to theta 2, or phi is equal to theta. The angle of incidence is equal to angle of reflection. The second law of reflection is saying that the incident light ray, the reflected light ray, and the normal line, all of them fall on the same plane, which is perpendicular to the reflecting surface. So the incident light ray, the reflected light ray, and the normal line, all of them lay on the same plane, is on the same line, and this plane is perpendicular to the reflecting surface. So, as we said, guys, types of reflection are two types: specular reflection and diffuse reflection. We have two different types of reflection. Specular reflection, the light rays reflect in the same direction, while the diffuse reflection, the light rays deflect or reflect on different direction. We have two types of mirror, guys. The plane mirror, which we already explained. A mirror is a flat sheet of glass covered by metallic material to be shiny and reflect light. A spherical mirror is a part of a sphere in which one of its faces can be or can reflect light. We have two types of images formed by the mirror, guys. One of them is a real image and the other one is a virtual image. What is the difference between them? When the light ray, the reflected light rays, intersect with each other, they form something called a real image. The real image must be inverted. For that, the images of different objects formed inside our eyes on the retina is formed inverted. Then the brain translated and modified to be upright. So the real image is an image that can be received on a screen, is the image that formed by the intersection of reflected light rays. Why? Virtual image, you can't see it or you can't receive it on a screen. You just see this image on the mirror. This image always be upright and formed by the intersection of the extensions of reflected light ray. Remember these two definitions. Later, by forming different images by spherical mirror, we will explain exactly how does each one of them is formed. So real image is the image which can be received on a screen, while virtual image cannot be received on a screen. Real image is always inverted. Virtual image is always upright. Real image is the intersection of reflected light rays. Virtual image is formed by the intersection of the extensions of reflected light rays. Here is the two laws of reflection. We said the angle of incidence theta equals the angle of reflection phi, or even the angle of incidence phi equal to the angle of incidence theta. Doesn't matter. The incident light ray, reflected light ray, and the normal line at the point of reflection all lay on the same plane, which is perpendicular to the reflecting surface. It's the second law of reflection. The properties which formed by the plane mirror, guys. The image is upright, so it's virtual. It's equal to the size. Laterally inverted, that's mean opposite direction. The right is left and the left is right. The image is virtual, can be received on a screen. So you have to connect between two concepts. When the image be upright, it must be virtual. The distance of the object to the mirror is equal to the distance of the image to the mirror. Let's explain this part, guys. Here is the mirror. Here is the plane mirror. You are standing in front of the mirror. So there's a distance between you and the mirror. Let's say that this distance is d. Your image will be formed behind the mirror at a distance which is equal to the same distance between you and the mirror, and at the same line. Each part located at the same line. So the image will be equal. Let's say it's equal at the same distance from the mirror as your distance, and the line which is joining the two parts of each object and image is perpendicular to the mirror itself. The straight line connecting the object and its image perpendicular to the surface of the mirror. Here are some definitions, guys, of incident light ray, reflected light ray, angle of incidence, and angle of reflection. As we said before, the incident light ray, it's the light ray that falls on the reflecting surface. The reflected light ray is the light ray that bounces from the reflecting surface. Angle of incidence is the angle of between the incident light ray and how many ants? A lot of ants. You always do this mistake, guys. And the normal line, not the reflecting surface. Scan the QR code and watch the video, guys. Let's say that I need to give you an example to fix the concept of angle of incidence and angle of reflection. Here is the normal line. This one is called the normal line. is a reflecting surface. Let's say here's the incident light ray, and here is the reflected light ray. What is the angle of reflection, guys? The angle of reflection is the angle between the reflected light ray and normal line. So the angle of reflection is equal to the angle of incidence, which is the angle between the incident light ray and the normal line. The angle of incidence is equal to 60. So the angle of reflection is equal to 60 also. Types of spherical mirrors. We're done with plane mirror, guys, so we are moving to another part called spherical mirror. Let's say that we have a sphere, a hollow sphere, like this one. We have a hollow sphere, and we cut this sphere to have just a part from this sphere. So this part is this bar, it's like this. We have two surfaces, the inner surface and the outer surface. Inner surface, say inner surface and outer surface. If the reflecting surface is the inner surface and the outer one is rough, so I will draw a roughy surface. This one called concave mirror. If the reflecting surface is the outer surface and the inner one is the rough one, so this mirror is called convex mirror. This mirror is called convex mirror. The concave mirror, when the light falls on a concave mirror, it will be reflected back on a pattern which make the reflected light rays be collected in a certain point. This point is called the focus of the mirror. The focus of the mirror. So the concave mirror collects the light, and the word collect is converge. It's equal to converge. So we can say that the concave mirror converges the light rays, which is mean collected at a point, and this point is called focus. This point is called focus. While the convex mirror diverging the light rays, that means the light rays which falling on this mirror unable to be collected. So the light rays will be diverged. So there's no intersection for reflected light rays, and we call that convex mirror diverge the reflected light ray, which is okay, guys. How to find the focus of a convex mirror? We said in concave mirror, the focus of the mirror is obtained by the intersection of reflected light rays. While at the convex mirror, I'm going to draw it again. Falling light rays. Here is the drawing of a light rays which fall on a convex mirror and be diverged after reflection. Note that, guys, the one at the center is falling on a certain point. This point is called pole of the mirror, and this only the light ray which reflects back on itself. So, if I will draw extensions of the reflected light rays, here are the extensions of reflected light rays. It will be collected at a point, intersect in a point. This point of intersection is called focus. But this time, the focus is found by the intersection of the extensions of reflected light rays. So it's virtual. It's virtual. Give me an examples, guys, for convex mirror. Convex mirror is a mirror which is found beside on the sides of car, at the entrance of a garage, to obtain an image. This image is virtual and also minimized. Okay, guys. So the concave mirror is a reflecting shining surface, is a part of inner surface of a sphere. It collects the light ray and called converged light ray. The convex mirror is a reflective shining surface, is a part of outer surface of the sphere. I need to learn you guys some concepts like what is the meaning of center of mirror, radius, pole of the mirror, principal axis, the secondary axis, the focus of the mirror, and the focal length. So I'm going to explain it on a concave mirror. Here's the concave mirror, guys. We have different radius, guys. Here's the radius, one radius, and here's another radius. As this point is called the center of curvature. The center of curvature. Any line, any radius from the center of curvature to the surface of the mirror is called secondary line. Secondary axis is called secondary except one. This one is the one which is joining the center by a point at the middle of the curvature, which is called pole of the mirror. This one, we will call it primary axis. Primary axis. So, we have two types of axes. One of them is a primary, which is join the center of curvature, which is the center of the sphere which the mirror is part of, to the pole of the mirror. Pole of the mirror is a point at the middle the middle of the mirror. This line which joins them, the center and the pole, is called primary. Any another line joining the reflecting surface and the center of curvature is called secondary axis. So we have only one primary axis, and we have different secondary axes, millions of secondary axes. The point of collecting the reflected light rays is called the focus of the mirror. The distance between pole of the mirror to the focus of the mirror is called focal length, and it's equal to the distance between the focus and center. So, as I can say, the focus point is located at the mid distance between center and the pole of the mirror. So the distance from the pole of the mirror to the focus is equal to the distance between focus and the center. So guys, now we are going to study the path of the light ray falls on a concave mirror. Let's say here is a concave mirror, and this concave mirror, the reflecting surface, as we said before, is the inner surface, and here is the principal axis, here's the center of curvature, and the focus, which is a point located at the middle or the midpoint between center and pole of the mirror. We have three different paths of light rays. The first one, which is fall parallel to the principal axis, so it's going to reflect back to itself. Going to reflect back to the center, and a light ray which falls passing by the focus. أنا رسمتها غلط. Okay, guys. Now we are going to study the different paths of incident light ray. We have different paths of light rays, guys, which falls on concave mirror. The first one, the light ray which is falling parallel to the principal axis. Here is the center, here is the focus point, here is the pole of the mirror. So when the light ray falls parallel to the principal axis, as we can see, it's going to reflect back on the focus. And while the light ray falls on the mirror passing by the focus, is going to reflect back parallel to the principal axis. And when the light ray falls passing by the center of curvature, it's going to reflect back on itself. So here is the concave mirror, here is the principal axis or primary axis, here is the center, and here is the focus, here is the pole of the mirror. When the light ray falls parallel to the principal axis, so it's going to reflect back to the focus. Notice that all of the light rays are straight lines. When the light ray falls on the mirror passing by the focus, it's going to reflect back parallel to the primary axis. If the light ray falls on the mirror passing by the center, it's going to reflect back on itself. The position of the object in front of the mirror is the one which provides the properties of the image itself. So we have 5 different positions of the object in front of the concave mirror. The first one is the concave mirror. The principal axis. Here is the focus and also the center. The distance between focus and the center is the same distance between the pole of the mirror and the focus. We said we have 5 different positions. The first one before the center. The second one at the center itself. The third one between the focus and the center. The fourth one at the focus. The fifth one between the focus and the pole of the mirror. So there are 5 different positions. Each one of them has a certain image, and the image differ according to the difference between the difference between different position of objects. Let's say if the object exists in front of the mirror at a distance greater than here is the center and here is the focus. At the distance greater than the focal length. Double the focal length. At the distance greater than the radius. At the distance which is located after the center. All of them is the description of the same position. At the distance greater than double focal length. At a distance greater than the radius. At a distance after the center. All of them describe the same position. So we are going to draw 2 light rays. The first one falling parallel, reflecting back to the focus. The second one falls to the focus, reflects back parallel. So here is the point, which is the light rays produced from, and here is the point of intersection. So here is the tip of the arrow. Here is the tip of the arrow, and the body of the arrow is here. As you can see, guys, the object is greater than the image. The object is greater than the image. So when the object exists at a distance greater than the radius, the image will be inverted, upside down. As long as the image is inverted, so it's real. Well done. It's real. As long as inverted, real, and as we can see, it's minimized. The second location is on the center. Here is the center, here is the focus, and the object is located at the center. So two light rays produced from the tip of the arrow, one of them is going to the focus and the other one going to parallel to intersect here. So here is the first one, parallel to the principal axis reflected back on focus, and the other one on the focus reflected back parallel to the principal axis. So the image is located just below the object. As we can see, guys, that both of them are equal to each other. So when the object located at the center, the image is inverted. And as long as the image is inverted, it's real. And the image is equal. Moving to the third position, which is between center and focus. Guess that, guys, as the object is moving towards the mirror, the size of the image increases. So I'm expecting the next one the image will be after the center and enlarged. Let's see that. Here is the object. Here's the mirror, sorry. Here is the mirror. Here is the focus. Here is the center. And the object located at a distance between the center and focal length. Two light rays, one of them going parallel and reflect back on the focus, the second one on focus and reflected back parallel. As you can see, guys, the image of the object just after the center and enlarged. It's inverted. Enlarged and maximized. Inverted, enlarged, and inverted, enlarged, and real. Inverted, enlarged, and real. If the object located at the focus, we have two descriptions for the image of an object that exists on the focus of concave mirror. Here is the concave mirror, here is the principal axis, here is the focus, and here is the center. The object exists here at a distance equal to distance equal to focal length, we have two light rays produced from the tip of the arrow, one of them going parallel, so it will reflect to the focus. And I'm not able to draw the second one passing by the focus, so I'm going to make it pass by the center. Passing by the center, which means the light ray going to reflect back on itself. Here is no intersection, guys. There's no intersection, so no image is formed. Or by another way we can call it, it's in infinity. The image is in infinity. There's no intersection between the light rays or even between the extensions of light rays. The last position is at a distance less than the focal length. By the way, guys, you are not required to memorize the drawing. You are not required to memorize how to draw it, but you have to memorize the drawing itself. So, here's the object at a distance less than the focal length, one of the light ray going parallel, so it's going to reflect back to the focus. And also I'm not able to draw one on the focus, so I'm going to draw the second light ray between the center and the image and the mirror itself, so it's going to reflect back on itself, making the extensions of the reflected light rays provides an intersection behind the mirror. This intersection provides an enlarged image for the object, upright. So as long as the image is upright, it's virtual and enlarged. So guys, here are the properties of the image defined by different positions. As we described it, at a distance larger than the radius of curvature, the image is real, inverted, smaller than the object, minimized, and located. The image is located between the center and focus. At the center, the image is real, inverted, equal, at the same size of the object, and the image is located also at the center. Between the focus and the center of curvature, so the image is inverted, enlarged, real, and at a distance greater than the radius. Between focus and pole of the mirror, the image is behind the mirror and virtual image, enlarged, upright. If the object exists at the center, no image is formed, or the image at infinity. The formation of image in convex lens, as we said before, the image itself always is virtual and behind the mirror. So the image will be minimized and upright and virtual, receive behind the mirror. You are unable to receive it on a screen. It is the image formed by convex lens. Here is a convex lens, and as we said, the image is minimized. The image is minimized. What is the relationship between the frequency and the wavelength of the light? The relation between them, let's write the rule, guys. V is equal to wavelength multiplied by frequency. So the wavelength is equal to V over F. As V is constant, the speed of light is constant, so the relation between wavelength and frequency, they are different to each other, opposite to each other, equal sign between them, numerator and denominator, so they are inversely proportional. While the wavelength and velocity are directly proportional. So the answer will be frequency is inversely proportional to the wavelength. What happens when two complementary colors are mixed? Complementary color are going to mix, so they are going to form a white color. Which of the following is a primary pigment? We have three primary pigments, not green, not blue, not red. So because green, blue, red are colors, not pigments. So it's cyan. Light refraction. What is the light refraction, guys? Light refraction is the change of light ray direction when it travels between two transparent medium as result of changing the speed of the light itself. As we can say, guys, as we know, guys, the speed of the light changes by the changing the medium. As there's something called optical density, which is the ability of the medium to transfer the light. The ability of the medium to transfer a light differs by different mediums. So it's going to make the light of the speed of the light going to make the speed of the light changes. As a result of changing the speed of the light, the direction of light will also change. This phenomenon, we call it the refraction of light. Here is a line which is separating between two mediums. Here is the normal line, which is an imaginary line perpendicular to the line separating the mediums. When the light falls on the line between the two mediums, it's going to reflect. If we suppose that the light ray going to move in a straight line, it will be like this. But it has two options. One of them, even to refract towards the normal line, so the angle of incidence is greater than angle of refraction, or to refract away from the normal line, so the angle of refraction is greater than the angle of incidence. It depends on the two mediums itself, guys. We have medium 1 and medium 2. If medium 1 has a density less than medium 2, so the speed of light will decrease and the light will refract towards the normal line. If medium 1 has a density greater than medium 2, so the speed of the light will increase and the light going to refract away. He is able to escape now, so it's going to refract away from the normal line. So in this case, theta 1 or phi is greater than theta, or theta 1 is greater than theta 2. In this case, phi is smaller than theta. Refractive index is the ratio between the velocities of light between the two transparent medium. It's the ratio of velocity of light between the two transparent medium. We can say that N equal V2 over V1. Here is the three refraction and how the light refracts towards the normal line or to refract towards away from the normal line. Snell's law. Snell's law is the law which is controlling the refraction of light, guys. Snell's law describes how the light ray refracts and the values of angle. As we said, n is the refractive index of the first medium, which is equal to c over v, the speed of light and the velocity of the light in a certain object. Notice that the refractive index is always greater than 1, as the maximum speed of light is c, which is the speed of light in vacuum, which is equal to 3 times 10 to the power 8 meters per second square. So the light has its maximum speed in space, and it's almost equal to in air. In air, almost have the same value, and we write as the same value unless he changes the value of the speed in air. The value of the speed of light in air is 2.99 times 10 to the power 8. So it doesn't make a big difference unless he mentioned that. So the Snell's law saying that the refractive index of the first medium multiplied by the sine of the incidence angle equal to the refractive index of the second medium multiplied by the sine of the angle of refraction. If the light going to refract between two mediums, one of them exists inside the first medium, so we will consider it as 3 mediums. The first medium is 1, the second medium is 2, the third medium is 1 again. Here I'm doing the reverse operation. What happened between medium 1 and medium 2 going to be reversed when the light passes from medium 2 to medium 1. Just shifting the light direction, it produced a light ray parallel to the main one, but shifted just in direction. Shifted, but still parallel. Here is the final law which you have to use during solving the problem. Sine theta 2 angle of refraction over sine angle of incidence equal to V2 over V1 equal to N1 over N2. N is the absolute refractive index, and as we said before, N equal to C over V. Total internal reflection, guys. Firstly, let's know what is the meaning of critical angle. What is the meaning of critical angle? Here is the light traveling through the same medium, so there is no light refraction, guys. If I change the first medium to be air, so a part of the light will refract, as you can see, guys. So increasing the angle of incidence increase the angle of refraction. Some of light ray can reflect without passing the line between the two mediums, as we can know not all of the light can pass through between two mediums. Some of them going to be reflected. Returning back to the critical angle, it's an angle of incidence in a medium with high density, having an angle of refraction of 90 in the medium of lower density. Now guys, here is the incident light ray, and here is the refracted light ray. As you can see, the light refracts away from the normal line. By increasing the angle of incidence, the angle of refraction also increases. To reach a certain angle, at this angle, the refracted light ray will be perpendicular to the normal line. This moment. After that, the light will be unable to refract. It only will reflect. So we're calling this angle angle of critical angle. We're calling this angle critical angle. It's the angle of incidence in the medium of higher density when it has its angle of incidence in the medium. Its angle of incidence. So the critical angle is the angle of incidence of the medium of higher density. Critical angle is angle of incidence when the light travels between two mediums. The first one is with higher density and the second one with lower density. At this angle, the light ray refracts with an angle of 90. So it will be perpendicular to the normal line. If the angle of incidence exceeded the critical angle, something will happen called total internal reflection. Total internal reflection is the reflecting of light rays totally in the same medium of higher density when the light falls with an angle greater than critical angle. So guys, total internal reflection, as we said, when the light falls from medium of higher density to medium of lower density with an angle greater than critical angle. One of the applications of total internal reflection is the endoscope. As we use a scope made of a plastic or flexible material coated with a material with lower density. So I force the light to travel from a medium of higher density, which is the material of the endoscope itself, to the material with lower density, which is the material that coats the outer walls of the endoscope. When the light falls with an angle greater than, here's the organ, which I would like to see. When the light falls with an angle greater than critical angle, it's going to do multiple internal reflection. So the doctor will be able to see the organ without making a surgery or a large surgery, detected by computers and different sets. It's the same idea of periscope. So the total internal reflection also is responsible for making the mirage. Mirage is a phenomenon that happens a mirage. It can form when rays it can form when light rays are refracted as they travel through air at different temperature. At different temperature, guys, the density of the light, the density of the air itself changes from one place to another place. So it's going to do multiple internal reflection for the real image. This multiple internal reflection keeps the properties of the image itself. As the layers near to the ground, near to the earth becomes, as the layer between near to the earth becomes more hot than the upper layer. So the light going to travel from the air of low temperature, which is more dense, to air with higher temperature, which is less dense. So it's going to do total internal reflection if only it falls with an angle greater than critical angle. Moving to another part, which is lenses. The lenses is similar to spherical mirror with only one difference. We are going to replace the two concepts of mirrors. So we said that the mirror, the spherical mirror, is a part of sphere. But the lens is the intersection between two spheres. If they are intersected like this, it will be a convex mirror. If they are touching each other, so it will be a concave mirror, a concave lens. So the intersection will provide a convex lens, and they are, as soon as they are beside each other, going to form a concave lens. The concave mirror converges the light rays. Here is the mirror. هنعيد الحتة اللي فاتت تاني من أول اللينس، حاجة صعبة مش هنرسمها تاني. مش هنعيدها، أقول لك على حاجة حلوة، هنتكلم كده من أول جديد. So we are going to make a comparison between lenses and mirrors. Here is the convex. Here is the concave. For mirrors, we said that convex make diverge as the light ray going to reflect back in different directions. Concave collects the light ray, so it's going to converge. Here is the shape of concave, and here is the shape of convex. Here is the convex lens. In lenses, the convex lens converge the light ray. Why? The concave lens divert the light ray. So lenses, it's a transparent medium that refracts the light. It is usually made of glass or plastic and is defined with two spherical surfaces. The lens, any lens, has two centers and two focus, as they are formed by two spheres, so it must has two centers and two focus. Here is the first sphere and here is the second one. So this sphere has this radius and this one has this radius. So we have two centers, and by the way we have two focus. Here we have the point at the middle. Instead of the pole on the mirror, we have a point here called O. O is the optical center. So the optical center located at the midpoint inside the lens itself. It has the same wave passes. The light ray which passes by the center will pass without refraction instead of refract on itself. The light ray which passes by the focus is going to refract parallel to the principal axis. The light ray which falls parallel going to refract to the focus, We have the same concept, the center of the mirror, the center of we have the same concepts, guys. The center of lens curvature, C, is the center of the sphere which is the lens is a part of. The radius of curvature is the radius of the sphere which the lens is a part of. The optical center of the lens is the point at the middle of the lens. When the light passes through this point, it doesn't refract. Principal axis is the line which joins the two centers of curvature. Secondary axis, any line that passes by the center and the lens. The focus is the point of collecting the refracted light rays. Focal length is the distance between optical center and the focus. We have the same properties for an object that exists in front of convex, not concave, convex lens, as it converts the light rays by the same properties like exactly the mirror. When the object is away from the center, the image formed between the center and the focus and minimized, inverted, real. When the object at a distance between the center and the focus, so the object will be the image will be after the center and enlarged, as here. When the object at the center, the image will be also at the center. Image formed by concave lens is similar to the image formed by convex mirror. The light ray going to refract, diverge away from each other, so the intersection will be by the extensions of refracted light rays to form a virtual focus. What is the meaning of vision defects, guys? Vision defects when the when a person is unable to see the image clearly. As we said before, the image is formed on something called the retina. Here is the eyeball, here is the lens, and here is the receiver, image receiver. So the image formed on the light rays coming from a distant object, so it will be converged and intersect on the retina to form an image. This one is retina. Vision defect when the light rays intersect at a distance less than in front of the retina, less than the diameter of eyeball, or at a distance greater than the diameter of eyeball, so behind the retina. By this way, the person is unable to see the image clearly. So this one, we call it short-sightedness, when the image is formed in front of the retina. When the image is formed behind the retina, we call it long-sightedness. So I need to fix this error. I need to modify the path of the image, the light rays, to form an image on the retina. I have two types of lenses. One of them is concave. This one is convex and another one is concave. The option or the function of convex lens is to collect the light rays. So if we have long-sightedness and the image is formed by the retina, I will use the convex lens to collect the light rays more and make the focus point exactly at a nearest point on the retina. If we have short-sightedness, so I need to push the image towards the retina, more a little bit towards the retina. By pushing it towards the retina, I need to diverge the light rays which is falling on the eye lens and make the distance between them a little bigger to collect it and push the image towards the retina itself. So short-sightedness when the image is formed in front of the retina, long-sightedness when the image is formed behind the retina. The correction in the case of short-sightedness by using concave lens, the correction of long-sightedness by using a convex lens. What is the Snell's law, guys? What's the Snell's law formula? N1 sine theta 1 equal N2 sine theta 2. At the critical angle, what happens to the angle of refraction? Becomes 90. Well done. Never say 0, because the angle is measured from the normal, so it will be 90. Which condition must be satisfied for total internal reflection? The angle of incidence must be greater than the critical angle. Which of the following statements about convex lenses is correct? They can form both real and virtual images. What is the effect of concave lens on parallel rays? Concave lens. It can form both real and virtual image. Concave lens. Concave, that's mean lens diverge. If I said concave mirror, converge. Concave lens diverge. So هيجي السؤال تاني، هعدله عيده. 11 ما ينفعش، هما شافوها خلاص. نحط الحل على طول بقى، مش مشكلة، أنا كده كان صح. نحط الحل بس. So the answer is the light rays diverge after passing through the lens. A person standing on a hot road on a sunny day sees water on the road. This phenomenon is an example of mirage. The image formed by convex lens when the object is infinity is virtual at infinity. لا طبعا هنيجي برضو الانسر. object at infinity تبقى الامج real at the focus. When the object at infinity, guys, that's mean all of the light rays falls on the convex lens parallel to each other. As the light rays falls parallel, so it's going to be collected at a point called the focus, as we said before. The light rays come from a distant object, away object, parallel to each other. So it will be collected at a point called focus. So the answer will be real at the focus. Light interference, guys. We have two types of light. One of them is called coherent light and the other one is incoherent light. What is the difference between them? Coherent light, guys, when the light rays have the same phase. What is the meaning have the same phase? Have the same phase, that they mean that have the same phase. That means they are in the same movement. They have the same amplitude at the same moment, the same crest at the same moment, the same trough at the same moment, and also they have the same wavelength. They only differ in amplitude. They have the same wavelengths, they have the same frequencies, they have the same crest point, the same trough point, but they differ in amplitude. Incoherent light is when the light whose waves are not in phase, such as a light bulb, as we can see from the two figures, guys. Young's experiment is an experiment which is used to find the wavelengths of a certain object. Let's say, guys, we have the design of Young's experiment here. Here is the monocoherent source, that means it has only one wavelength. The light rays coming from a single slit. Then the second screen consists of two slits, two arrows, as the first slit just exists at the middle distance, in front of the middle distance between slit 1 and slit 2 for the second screen. The two slits, the two holes, provides two coherent sources. Instead of making two coherent sources by a certain set, and they may differ in phase, by this way, I'm assuring that the two sources are coherent, as the wave going to reach each of them at the same time and the same phase. So now we have two coherent waves produced from the first slit and the second slit. They will make something called interference, as they provide different frames. One of them is bright and the other is frames. The central one is bright, which coming from the interference of 2 points similar to each other, crest with crest, trough with trough, or a dark one which is coming from the interference of 2 opposite points like crest and trough. The constructive interference produces bright fringe. Constructive mean increasing the intensity. Destructive interference produces a point called dark, which is mean decrease in the intensity of the light. The rule of this experiment is called delta Y. Delta Y is equal lambda d over r. Lambda is the wavelength to be measured. Delta Y is the distance between two similar fringes, two successive fringes and similar. R is the distance from the screen to the double slit. This one is the screen and this one is the double slit. While D is the distance between the two holes or the two slits themselves. D. As we are doing an experiment, so for us, D and R are known. So if we measure delta Y using a certain tool on the screen, the receiving screen, so we are able to find the wavelength. Types of fringes, guys. We have two types of fringes, dark fringe and bright fringe, as we said, and how to find them. Delta L or delta Y is the distance between the central point and the next fringe. So if you said that, you need to find delta L, and you are using the first dark, or let's say first bright. For the first bright, it's in the order of y, as we said before. Delta y or delta L is the distance between two successive similar fringes. Here, the distance from the central bright to the first bright is delta y. The distance between the first bright to the second bright is 2 delta y. The distance between the center and the third is 3 delta y. But the distance between the first bright and first dark is half lambda, half wavelength. So we have to modify the rule itself between applying the bright fringe and the dark fringe. Here, delta L is equal n lambda, as the distance between the central and any fringe will equal to multiple number of wavelengths. But here, the distance between the bright, the central bright, and any dark will be halves of the wave. Half wave length, 1.5 wavelengths, and so on, 2.5 wavelengths, and so on. So delta n is equal to n plus 2, n plus half lambda, or delta n equal n lambda in the different cases of dark fringes and bright fringes. So the rule will be y equal m lambda L over D. L is the same of R, the distance between L is the distance between the two slits and the screen. M is the order of the fringe. D is the distance between the two fringes. We have another type of interference, guys. We called it thin film interference. As you can see, these thin films represent two different mediums. So it can provide a kind of coherent sources. As long as we have a coherent sources, we can have interference. Here is the light falling on the first. Let's use this one. Here is the light falling on the first surface. So some of the light going to reflect and other going to refract. The refracted one will reflect back to provide opposite refraction in the first case. So the two light rays will be parallel to each other. These two light rays may make interference similar to the interference done by Young's double slit experiment. So the thin film interference, the phenomenon of a spectrum of colors resulting from constructive and destructive interference of light waves due to reflection from separate surface in a thin film is called thin film interference. And you guys can notice that when you hold a CD, or a computer CD, and you can notice some colors provided by the lower part of the CD itself. It's a kind of interference, guys. The next one is the light diffraction. The light diffraction, when the light passes by the edge of a thin, of a sharp edge, when the light passes by a sharp edge, or by a hole slat, or this hole has a dimension of the wavelength. Has a dimension of the light wavelength. So it's going to diffract. Diffract, that means change its direction. Change in direction. The change in direction of the light may lead to something similar to the interference by overlapping between the diffracted light ray and the main light ray. So the diffraction pattern is a pattern of a screen of constructive and destructive interference. As we said, some of the light going to diffract, which pass through the narrow point, the narrow hole, and another one going to keep moving without diffraction, so interference may occur. The result of this interference, which resulted from the diffraction, is similar to the normal interference done by two coherent sources. In Young's double slit experiment, the distance between two slits is 0.2 millimeter. If the wavelength of the light used is 500 nanometer, and the distance between the slits and the screen is 2 meters, what is the distance between the first and the second bright frames? Let's focus, guys, and I need to solve this one. We are talking about Young's double experiment. So delta y equal lambda r over d. Lambda r over d. So عشان تحت خاصة لازم ترجع تقص الحتة دي. أو مش هينفع اخد سكرين شوت هنا واثبتها. And the rule will be lambda r over d. Delta y equal to lambda r over d. So the rule of Young's experiment, double slit experiment, is lambda y, delta y equal lambda r over d. خد الحتة دي وحطها هناك. So the rule itself will be delta y lambda r over d. The distance between two slits is 0.2 millimeter. The distance between two slits is 0.2 millimeter. So it's d. The wavelength used is the lambda. And the distance between the slits and the screen is 2 meters, which is r. Distance between first and the second bright frames. We're going to add m for the order of the bright frame. delta y for the first will be 0.2 millimeter multiplied by 500 nanometer. So I would like to change from 500 nanometer into millimeter. So from nano, which is which is 10 of power negative 9 to milli, which is 10 of power negative 3. So I'm going to subtract the power. So negative 9 minus 3 would be times 10 of power negative 6. Divided by أنا بغلط. بص شيل المسألة دي خالص، شيل المسألة دي خالص، لا تتحل بعدين، شيلها خالص. هنبدأ من هنا. What is the condition of constructive interference to occur in Young experiment? Delta L equal n lambda. In a diffraction experiment, the first minimum in diffraction pattern observed at an angle of 30. If the wavelength of the light used is 600 nanometer, what is the width of the slit? مش علينا دي، شيلها. حطيت أسئلة وخلاص. In Young's double slit experiment, the slits are 0.5 millimeter apart, so it's D is equal 0.5 millimeter apart, and the screen is 1.5 meter away, or is 1.5 meter away. The wavelength is 600 nanometer, and what is the distance between the first and third؟ طب ما هي نفس المسألة يا جماعة، ولكننا شفناها. What happens to fringe widths in Young's double slit experiment if the wavelength of the light increased? The fringe widths increase again. هعيدها تاني. What happens to the fringe widths in Young's double slit experiment if the wavelength of the light is increased? The fringe width also increases. So guys, we reached the end of our lesson. Study well and prepare your questions for the live session, inshallah.